Good morning, everyone. Welcome back. Today we're going to do Unit 2, Day 8. We're going to continue talking about writing the equation of a line, Part 2. We are going to define slope and define y-intercept. So those are two of our major goals today, is to talk a little bit more in depth about the slope and the y-intercept. So we're going to be adding on to what Mr. Rule was talking about in his lesson yesterday. And then we're going to take that more in-depth idea of slope and y-intercept and apply it to writing equations and identifying the slope and y-intercept if we were given an equation. All right. First thing we got to do, we got to review just a little bit here. So we're going to review solving an equation. Now, recall from previous review sessions, we talked about what it means to solve an equation. And that means that we're trying to find a value of x that will make this thing be true. So in other words, whatever number I come up with for x, if I plugged it in for x, I would get the same number on both sides. All right, so how do we do that? Well, we move things from side to side of the equation until x is all by itself. And we do that by adding and subtracting and multiplying and dividing. But the one thing we have to keep in mind is that whatever we do on one side of the equation, we have to do on the other side. Okay? So we always kind of demonstrate this by drawing a line, and we start picking something to move. Now this one looks a little complicated because it has an x on both sides, and since we're trying to get x by itself on one side, it would make sense that we need to get all of our things or all of our terms that have an x in it on one side of the equation. So I'm going to start by moving this 3x. And since it's a positive 3x, I'm going to do the opposite, which means I'm going to subtract 3x from both sides. Okay. So working left to right, 6x minus 3x leaves me with 3x. I still have a plus 6. And then on the right side, these cancel and become 0, so all that's left is a 7. So now it's a little bit easier, right? We only have one thing that has an x now, and we need to start moving everything else to the right side. So this 3 and the 6, it needs to go. I'm going to start with the 6. All right, so I'm going to subtract 6 from both sides because it's adding 6. So subtracting 6 would be the opposite. All right, and then again, working left to right. Nothing happens to this 3x, so I'll just write 3x. The 6's cancel. And over here on the right-hand side, 7 minus 6 is 1. I hope you didn't use a calculator for that. All right, last step here, right? All we have to do now is move this 3 to the other side. No problem. How do I do it? Well, it's multiplying right now, right? So 3 times x. So to undo multiplication, I would have to divide. So if it's multiplying by 3, the opposite would be dividing by 3. All right, so here 3 divided by 3 becomes 1, and those cancel, so I have 1x, which is what I wanted. And then we have 1/3. All right, and 1 divided by 3, you could write that as 0.3333 repeating. And when you go to MyOpenMath and enter in your answer, make sure you round your answer to 3 decimal places. So if I were going to MyOpenMath, I would simply type in 0.333, or you could just type in 1 divided by 3. MyOpenMath will accept either one of these answers when you do this practice problem today. All right, guys, that's our review for solving equations. Hopefully you found that enlightening. So let's get back to our major topic, which is building the building blocks of a line. All right. So yesterday in our video, Mr. Rule talked about the basic equation of a line, and typically what we are going to see for equations of lines are y equals mx plus b. We're going to see this a lot. All right. There are other ways to write equations of a line, but this is by far the most famous way to do it, the most common way to do it. All right, and we call this slope-intercept form. All right, and that is because it uses two pieces of information to write the equation. It uses the slope and it uses the y-intercept, so it makes sense to call it the slope-intercept form. All right, so you'll notice some things in here like y and m and x and b. We know what the y and the x represent, right? X represents the input of the equation and y represents the output. We've been talking about that for a while, but now we have these other things, m and b. All right, and m represents the slope. All right, and we're going to talk about what slope is in detail here, but it represents the slope of the line, and b represents the y-intercept. Okay, so we have to be able to identify these two pieces of information if we're going to be writing equations for lines. All right, so let's talk a little bit about the slope. All right, the slope essentially measures the steepness of a line. It gives the line direction in terms of its rise and run. So for instance, if I were to draw a line here on my graph, okay, so let me insert a line here. Let's say draw line. All right, so let's say I put a line right here like this. So there's a line, right? And this line has a particular steepness to it. All right, so right, if you could imagine like this was a hill and I were climbing this hill, right, the steepness of the hill starts to become important because it determines how hard it is to climb that hill, right? So if I were to reduce the slope, I could grab this line and I could make it less steep, right? This would be an easier hill to climb. So that would be reducing the slope. If I wanted to make it a harder climb, right, I would move the line like this so that it's steeper. All right, and that's what the slope tells us. It gives the line a direction, right? It tells me where to point this line and in what direction. Also, if we had a negative slope, right, so we would see something like this rather than going uphill, right? So remember, I was going like this, I was going uphill. Now I'm going downhill, right? So I'm walking down the hill. So this would be a slope that is negative. So slope can take on many different forms, but essentially what we look for is this thing called rise over run, right? And this tells us how steep our line is, all right? So let me demonstrate that here in our graph. Grab a nice bright color, and let's say I put 2 points on this line, just like that. Okay, the rise, if I were traveling from this point to this point, the rise would be the vertical change going from point A to point B. That's my rise. The run would be the horizontal distance that I travel going from point A to point B. So this horizontal distance here is our run. All right, and they might give us the slope in a number of different ways. They might say, hey, the slope is 3, right? Or the slope is 1/4, right? So they might give us something like this, like a fraction, right? In which case, the fraction is actually nice because we can see explicitly what the rise and the run is. Right? So this is telling me that I'm going to go up 1 and to the right 4. This one, not so clear, but it's a whole number, so I can always rewrite it like this, 3 over 1, and now I can see that the rise is 3 and the run is 1. And remember how I said I had a negative slope, so a negative slope might look like this, right? So let's say I have a slope of 2/3, and I put a negative out front like this. That would indicate that I'm going downhill now, okay? So this would tell me that I have a rise of 2 and a run of 3, and we would have to assign this negative to either the top or the bottom of the fraction. So I might do this. I might say negative 2 over 3. And this would tell me that I'm going down 2 and right 3. Okay? So that's a more in-depth look at what rise and run means. Now this over here, Mr. Rule kind of talked about this yesterday in the lecture, and this is a more technical definition of what the slope is, all right? So we say it's the change in y over the change in x, and like I said, this is a very precise mathematical definition. We're going to focus more on this type of definition. It's a little bit more loose and allows us to conceptualize that steepness of the line. This is more of a calculation to find slope. So if I did know the location of these 2 points, I can take the information from those 2 points and plug it into this formula to calculate the slope. All right, we're going to do that later, and so we will come back to this, but for now we're focusing on this. All right. All right. Last thing here that I want to talk about before we do some problems is the y-intercept. Okay. And the y-intercept is a really easy thing to understand. It's just a location where the line crosses the y-axis. So if I were looking at my example line up here, I'm looking at this point where it crosses the y-axis. Okay, that's all it is. And it's going to have a location, right? It's going to have a coordinate for that point, and it's always going to have an x-coordinate of 0, and then there will be some value here that we call b, right? That's the piece that goes in our equation. Right? What we'll get a lot of students, I'll say, hey, what's the y-intercept? And they'll say 3. this would be wrong. Okay, remember when I say where is the y-intercept, it is a coordinate, so you would have to say 0, 3, and make sure you complete it with a set of parentheses. It's the most common mistake that students make, so make sure that you are writing it as a point on a graph, not just the 3, not just the number. All right, let's give some problems a try. All right, so in this first set of problems here, we have some equations, right? They give us the equations. These are all in y equals mx plus b form. So remember we talked about the equations of lines looking like this, right? Y equals mx plus b. So the first thing they want us to identify is the slope, right? So remember m is the number that is in front of x, right? So I'm looking at this entire fraction that is in front of my x from the original equation. So I can simply say that my slope is 3 over 5. Right, this being my rise and this being my run, up 3 over 5. All right, now the y-intercept is located over here on the end. I know it says plus b and this says minus 2. That's okay. It just means that b, all right, the b value in our coordinate is going to be a negative 2, right? So a lot of you might say, well, the y-intercept's negative 2. Remember, it is a point. And the point is always 0, comma. Right, because it's a y-intercept, the x-coordinate will always be 0. So I'm going to say 0, comma, negative 2, and complete it with a set of parentheses. Right. So let's look at the next one. All right, you're probably thinking, oh my gosh, Mr. Weldon, it looks like we're missing something, right? Because if I'm thinking about my general form of a line here, or the equation of a line, y equals mx plus b, I don't see the plus b part over here. All right, not to worry, I'll show you what to do about that. All right, so again, slope is the number in front of the x, and we can clearly see the 2/3. So I'm going to say 2 over 3, meaning I'm going to go up 2 and over 3. Right, up 2, right 3. Rise, run. Y-intercept. There's nothing here. Okay, not a problem. What number represents nothing? Well, that would be 0, right? If I had nothing, that would be 0 of something. So 0, right? But we want to make sure we write this as a coordinate, so we're going to say 0, comma 0. Make sure you put a pair of parentheses around it to complete the coordinate. All right, so if you wanted to, you could say plus 0 here, right? And it would be the same thing. 2/3 x plus 0 is just 2/3 x, right? So they don't usually write the plus 0 in these scenarios. Okay, let's try it again. So here we go, and you're probably thinking, oh my gosh, Mr. Weldon, I don't see a number in front of the x. All I see is this negative sign. What is going on here? All right, no problem. All right, so normally if we don't see a number in front of an x like that, we get to assume there's a 1. Okay, we don't always write 1x, instead we just say x, right? So if you see an x, it's assumed that there's at least one of them, unless there's a number in front of it that specifies that there's more. So if we don't see a number in front of it, we get to assume that there is at least 1. And since there's a negative here, we get to say negative 1. So when I write my slope, I'm going to say negative 1, and you could even take it a little bit further and just say negative 1 over 1. That way you can distinguish the rise and the run. So this is one of those slopes that's going to be going downhill. All right, so we're going to go down 1 to the right 1. Okay. Now we look for our y-intercept. So we have a 3. So I'm going to say 3, and then I'm going to remember to write it as a coordinate. So I'm going to say 0, comma 3 with a set of parentheses. All right, last one here. And you're probably thinking, oh my gosh, Mr. Weldon, I don't even see an x in this equation. No problem. All right, so remember, we're looking at y equals mx plus b. We don't see the x part, right? So it's like this entire part of the equation, the mx part, is not there. Okay, and remember, the number that represents nothing is 0. So in this case, our slope is simply 0. Okay, so it has no rise. And you can say the run can be whatever number you want it to be. If it's not going up, it doesn't really matter how far it goes over. Whatever you do, don't put a 0 in the bottom here. So you can say 0 over 1, 0 over 2. Doesn't matter. The slope is 0, and that means it's going up nothing and over whatever you want. Okay. Now the b part is still there, right? The 5 is still there. So this is going to cross the y-axis at 5, but specifically it's going to cross at 0, comma 5. All right. Those were some interesting problems, right? A little bit different than yesterday. All right, that's why we got to talk through those and look at those different scenarios. All right, but we're going to go the other direction now. All right, so instead of giving you the equation, I'm going to give you the slope and the y-intercept, and I want you to write the equation. All right, so here we go. So this one, all right, we know that our equation is going to look like this, y equals mx plus b. So we need to find these two things, m and b, which they give us over here. All right, so the slope is 7/3. That's easy enough. I can take that 7/3, and I can come over here, and I can simply plug it in for m. So now I have y equals 7/3 x, and then we need our y-intercept. And remember, we're not going to put the coordinate in for b, right? We just take the y value here, just the 4, and we're going to say plus 4. And that completes my equation. Okay, so pretty easy, pretty straightforward. All right, so let's try another one. All right, so same thing here. We got y equals mx plus b, and my slope is a 1. So I'm going to come over here for the m value, and I'm going to put in a 1x. And then I look at my y-intercept, and it's a 0. Right, so this y-coordinate is a 0. So I'm going to say 1x plus 0. And this is perfectly acceptable. You can write this like this, but remember what I had said in the previous problem is that typically if we have 1x, we just write x. And typically if we have a plus 0 on the end, we just don't write anything at all. Right, so we can actually leave our equation like this, y equals x. Either one, MyOpenMath will accept. This is probably the more formal way of writing our equation. Most mathematicians would not write all of the extra stuff. All right, last one here. All right, so we got y equals mx plus b. I always start with my blueprint, and then I go get my information. So the slope is 0. Okay, so I'm going to plug that in for m. So I got 0x. And then we have a b value of -6. So I'm going to say 0x minus 6. All right, so let's think about this a little bit. We can simplify this a little bit because 0 times x is just 0, right? 0 times anything is 0. So I can just look at this and put a 0 there. I don't need the x anymore, right? And then if I do 0 minus 6, well, that's just -6. So my simplified equation would look more like this. Right, just y equals -6. It's the same thing as this, right? And like I said, MyOpenMath will accept either one of these, but this is the better way to write it. All right, guys, that's it for today's lesson. Give the practice problems a try, and if you have questions, we will get back to you tomorrow. Have a great day.